Hello students, I hope that you have completed the remaining problem of your exercise 3E, and today I am going to start the remaining question of your exercise 3E. Before starting this question, I want to revise your topic terminating and non-terminating decimals. First is terminating decimal. Terminating decimal. Means that if you are changing any fraction or a rational number into a decimal, okay, when it after a few steps of division, if its remainder gets 0, if its remainder is equal to 0, then the given rational numbers are fraction are said to be terminating decimals after few steps. Suppose if I have taken here 7 upon 8, okay, 7 upon 8, okay. So if we are dividing this one 7 by 8, after few steps of your division, if its remainder gets 0, then the given quotient representing a terminating decimals. See this one, 7 is not divisible by 8, so take a 0 and points 70. 7 8 8 is 64, 6 downside cancel out 60, 8 7 is 56, 4 is there, then you have taken a decimal, so 0 you will increase in each step. 8 5 is 40. So you can see this, after few steps its remainder is equal to 0, means that, okay, so the given quotient is representing a terminating decimal. So students, you always remember that if you are dividing, means that any division you can check up to a 5 step. After 5 6 step, it's if it is equal to 0, before that if it is get 0, no problem, but if it is not getting, you can check that up to 5 or maximum 6 decimal places. If it is not equal to 0, then it is not a terminating decimal. It is a second one is your non-terminating decimal. Okay, non-terminating decimal. Non-terminating decimals. It is a two types. Non-terminating means that after division, if you are doing division, its division never ended, never comes to end, means its remainder not is equal to 0. Means if you are doing a division but your remainder not equal to 0, like you can see this one, if you are dividing 1 by 3, instead you have taken a fraction 1 upon 3. If you are going to divide this one, see this one is not divisible, so take the decimal 10 9 1. You see this one again 3 9 1. You can see this, if you are doing this division, 1 comes in each remainder, it once comes, so it is not equal to 0, or not is equal to 0, means that division never ended. So this type of decimal numbers and so on, this type of decimal numbers are said to be a non-terminating decimal, and it is a two types. Non-terminating decimal is a two types. Here you see this one. First one is a recurring or repeating decimal. Repeating decimal means that after few steps, a digit or a block of digits are repeated. In this one, second one is a non-recurring, non-repeating. Non-recurring, non-repeating. means that it is not going to be ended, it is not repeated also. Means that you are going to do that your division, but the terms are not repeated after a few points. It always comes a different numbers in the decimal, in the quotients. Non-recurring means that non-repeating. Okay, see this, if you are doing this division, suppose I will show you with examples, and I have shown you that example is that 4.3547 and so on. It is not repeating this decimal points. In the decimal points it is not repeating, like 0.404004000. It is not repeating, students. It comes different. No, here is 1 0, here 2, here 3. Means it is not repeating decimal points. Okay, so it is a non-recurring, non-repeating. This one is a recurring or repeating decimal. Means after few steps of your division, it going to be repeat. Suppose one interesting example, 1 upon 7. I will show you this one. 1 upon 7. If you are doing this division, see this one, points 10, 1 times 7, 3, decimal you have taken 30, 7 4s are 28, 2, 20, 7 2s are 14, 6, 7, 8 is 56, 4, 0, 7 5s are 35, 5, 0, 50. You can see this one. After 5 steps of your division, 1, 4, 2, 8, 5, you can see this one. It is not repeating. You think that it is not repeating, but after a 5 step, you see this 7, 7 49, 1. You can see this. After 6 steps, it is going to be repeated. 10, then 1, 7, 3. Here you see this 3. 3 is again divisible by a 7. 3 is remaining here, so I am going to divide it here. 4. So you see this one. After 6 terms, it is repeated. So this is you will get it 0.142857, and then after it is going to be repeated 142855857. Okay, and so on. So after 6 steps, this is going to be repeated. Okay, so this is called a recurring repeating decimals, and this is a non-recurring non-repeating decimal. Means that it is not repeated, but division is not. In this case also, remainder not is equal to 0. In this case also, remainder not is equal to 0. So by using these two, by revising this one, I'm going to do that remaining problem of your exercise, question number 2 and question number 3. Firstly, I am going to do that question number 2. Exercise 3, question number 2. Express the following fractions as a recurring decimal. Recurring means that it is a repeated. After a few steps of your division, this term is going to be repeated. Okay, so this is called a recurring decimal. So first one is see this in your solution. 1 upon 3. If we are going to divide by using a long division method, if I am dividing this one, 3 is going to divide 1. 1 is not divided, take a 0, 3, 10. So, sorry, it is a 9. Okay, so 1 comes, again decimal you have taken 3. See this one, 1 upon 3, students. Divide this one by using a long division method. I am going to divide it here. Okay, take 0, 3 times 3 3s are 9, 1. Okay, you have taken a decimal, so you increase 1 0 in each step. Again 3 3s are 9, 1. You can do this up to a 5 step, 9, 1, 3, you have taken a 0, 1, one more step, same thing you are getting it, 1, means that remainder not is equal to 0, means that it is a repeating decimal in this case, because 3 is going to be repeated and so on. So 3, 3, 3, 3, 3 and so on. So what is your answer? 1 upon 3 is equal to 0.3 dot r. You will represent with a bar, 0.3 bar, because one term is repeating, so you can put 1 bar. You can put on that number, you can put the bar or dot on that one. Okay, now that question number 2nd, see this one and complete it in your copy, student. Now this question number 2nd. So before going to do this question number 2nd, I'm going to erase this one. See this one, question number 2nd. Okay, 1 upon 9. So here I'm going to do this one division. 1 is not divisible by 9, so take this decimal point. 1 times 9, 1, again it comes 1, 0 you have taken, so 9, 1, 0, 1, 9. You can see this one, a remainder not is equal to 0, means that it is also a non-terminating but recurring decimal. So you get this 0 point and so on. This one comes, okay, so 1, 1, 1, 1. You can write it up to 5 step, okay, and that your answer is a 0.1 dot r. You will write it or 0.1 bar. Okay, this is your answer. Now that question number 5th one. Okay, this is your question is 4th one, 1 upon 11. I'm going to do this 1 upon 11. Question number 4th, 1 upon 11. 3rd one you will try with yourself, because I have done that one in example. Okay, so see this one. 1 is not divisible by 11, so take this decimal point, 0. 10 is also not divisible, so take one more 0, 100. So 11 nines are 99. 1 is there, cancel out. You have taken a decimal, so take 0. Okay, so but 10 is not divisible, so take you another 0 to here. Okay, so 100, 9, 99. If you are subtracting, again you will get this 0. 1 is not divisible, take decimal, 0. 10 is not divisible, take another 0. So again 9 times. So you can see this one. It is also a non-terminating but recurring decimal. R not is equal to 0. 0, 9, 0, 9, 0, 9 and so on. Again it comes 0, 9 students. 0, 9, 0, 9, 0, 9. So your answer is okay, hence 1 upon 11 is equal to 0.090909 and so on. So you will write this 0.09, or you will put the bar, 2 bar on that one. 0 is also repeating, 9 is also repeating, dot. Okay, R in form of a bar, you will write 0, 9, single bar on that one. Okay, so this is your question number 4th. Now that question number 6th one is 50 upon 11. Question number 6, 50 upon 11. Okay, this is the question number 4. 5th one you will try. It is the same as it is like a question number 3rd. Now this question number 6th one, I think. Question number 6, 50 upon 11. I'm going to do this one, 50 upon 11. 50 upon 11. So see this one, here I'm going to do this division. 4 times 44, 6 carry, cancel out, 6 is not divisible, take a point. 65 times 55, 5, 0, 4 times 44, 6, downside, 5 times, again means you can see this one 4, it repeat 5 4 5 4, again it comes 5 4 and so on and so on, it comes again, it comes 5 4 5 4 and so on. So its answer is equal to, hence 50 upon 11 is equal to 4.545454 and so on, means that 4.54. Put 2 dots R, you will write 4.54, one single bar on that one. So your answer is a 4.54, student. Next one is a question number 7. After this I'm going to question number 7. 0.08 upon 11. So I'm going to do this division, okay, by using a long division method. This points is not divisible, 0 is not divisible, so take this point in your quotient, take 0, okay, because 0.8 is not divisible, okay, so you can increase 1 0. This is 80 is divisible, so 7 times 77 on this one, 3. So because you have taken a decimal, so take 0 there. 2 times 22, 8, again 87, 77, 3 comes, see this one, you know this, all that you remainder not is equal to 0 in this case also. 3, 30, 2, 22, 8. So remainder not is equal to 0. After that it comes 7 2 7 2 7 2. What is repeating in this one? 7 2. So your answer is for this case 0.08. Sorry, here you can see this one. See this one, your answer for this case 0.08 upon 11 is equal to 0.007272 and so on. 72 only comes, so it is repeating only 72, so 0.072. 2 dots on that one, means 7 and 2 are repeating, or you can write it, or you will write it 0.0072 on that, you will put the bar. So this is your question number 2. After that I'm going to do that question number 3. Let's see this question number 3. Express the following recurring decimal as a fraction. First question is 0.3 dot or 0.3 bar, means that this decimal, this recurring decimal, you can change as a fraction. So very easy, students. If you are doing this type of a question, so you can remember that few steps, okay. First you can change this one in form of a recurring decimal, okay. So suppose question number first is this one, solution for this first, okay, 0.3 dot or 0.3 bar, you can change in form of a recurring decimal. 0.3 dot means 3 is repeating in this one, 3 3 3 and so on, okay. So this is your equation 1. You can tell this is the first equation. So one term, if it in your question, if it is one term is repeating, so you can multiply with 10 in both side. This is a left hand side and this one is a right hand side. Multiply by 10. Multiply by 10 both sides. Both sides we get. If you multiply by 10 in this one, you will get this 10 is multiplied 0.3 dot or bar. I'm using a bar here, okay. And if you are multiplying this one in 10, so 1 3 comes to this side, and then here you can use a 4, okay. This is equation 2. So here is a one confusion, students. You have seen this, there is a 4 3 I have taken, and then dot. Here also I have, because this dot means that 3 comes, or our aim is to change this one as it is. If we subtract this one, then the decimal point should be 0. We get only a natural number. Okay, if we subtract equation 1 from equation 2, then the after the decimal points should be 0. That's why we change it in this form. Okay, because and so on it comes 3 and so on. So if you multiply with 10 in this one, because one decimal point is there, so you will multiply with 10, then 1 3 shifted this one, and we can take as much 3 as in equation first. Okay, so see this one, here is a 4, here is also 4, and so on. So subtract equation 1 from equation 2. Subtracting equation 1 from equation 2. So left side we are subtracting this one. Here you see this one, 10 into 0.3 bar minus 0.3 bar, okay, is equal to, if you are subtracting this one, then 3.33 and so on. Here is 0.3333 and so on. Means that if you are subtracting, you get the 3 0 0 0 and so on. After decimal points only zeros are there, nothing is that one. So you will write this one you will write directly, or you will take one more step, 3.3333 and so on, minus 0.3333 and so on. Student, you can do like that. Okay, and so on. If you are subtracting, here you see 0.3 bar, 0.3 bar. If you take this common 0.3, if you are taking as a common, or here is a 10, 0.3 bar as a common, 10 minus 1. Here if you are subtracting, you will get this 3.00 and so on. Okay, and so on. So you get this one, 9 is multiplied by 0.3, 10 minus 1, 9, here 3. So 0.3 bar is equal to 9. You will transpose to this side. Here is a multiplication. If it goes to right side, multiplication change into division. Okay, 3 upon 9. And if you change this one into a simplest form, you will get 1 upon 3. 3 1s are 3. So in next step, you can change it into a 3 upon 9. Then you will change it into a simplest form, 3 1s are 3, 3 3s are 9. So this is your answer, or you will write it hence 0.3 dot or 0.3 bar is equal to 1 upon 3. This is your answer. So but listen students, one more way you can do it directly. If you use your concept, if you use your mind, you can do it directly. Here is a 1 bar, 0.3 bar means that 3 you will write as it is. Here is a point, so take this one. Here is a 1 decimal points repeating, so you can write 1 9. Okay, 3 upon 9. This one is your answer. Same as it is. Here is a 6, 0.6 dot 6 upon 9. Then 2, 3. Your answer is a 2 upon 3. But if it is asking in your standard, you can do with this way, or you can suppose this quantity as a x also, and then you will do it. Okay, so question number 2 I will use with that concept using to suppose this one as a x. So in your solution, let x is equal to 0.6 bar. Okay, so change this one is equal to 0.6 bar means 6 is repeating, 6 6 and so on. Okay, this is, if you take this one, x is equal to 0.666 and so on. This is your equation 1. Multiply both sides, multiply by 10 both sides. we get. Okay, so if you multiply 10 in this x, you get it 10x is equal to, if you multiply 10 in this one, 6 comes to this, your point shifted 1 point to the right side, 6.66, because our aim is to make a equal decimal points after a decimal number after this decimal points. Here is a 4, 6. So in this second equation also we will make this 4 decimal points. Okay. Then after, if it is a equal, this right side of from your decimal points means after decimal points, if your numbers are equal, then we are going to subtract the equation. Here this equation is 4, 6. Here is also 4, 6. So from equation second, I'm going to subtract the equation 1. So subtracting equation 1 from equation 2, we get 10x minus x is equal to 6 minus 6, 6, 6 and so on, minus 0.666 and so on. Okay, if you are subtracting, you are getting this 6.000 and so on. Here you get it 9x. So 9x is equal to 6, then x. Here is the 9 is multiplication, is goes to right side. Multiplication change into division. You will get 6 upon 9. Change it into a form of a simplest form. Okay. So it is cancelled out by 3. 3 2 is 6. 3 3 is 9. You will get this 2 upon 3. So x, you have supposed this 0. What is the value of x? Hence you can see this one. Hence x is equal to 2 upon 3. X is, you have supposed that 0.6 with dot r bar is equal to 2 upon 3. This is your answer. So it is easy now, students. Both way you can do that. First I have done it without supposing it x, without supposing it a unknown quantity. It is also easy, and this way also you can do that one by supposing x. Okay, now that question number third one. Okay, 0.13 bar third. Okay, students, so in your solution we suppose this one, let x is equal to 0.13 bar. Okay, or you will write this one 0.13, 3 only repeating, so 3 3 3 and so on. This is your equation 1. Okay, this is the value of x. Here is a one term is repeating, so you can multiply firstly 10. Okay, multiply by 10 both sides we get. If you multiply with 10, you will get 10. If you multiply this side, 10x is equal to, if you multiply this one with 10, 1 comes to this side, 1.3333 and so on. This is your equation second. Again you can see this, here is a 1 3 3 repeating, here is a 3 3. Both are unequal, so you cannot subtract this one. Again you will multiply with 10. You can make that both that decimal points are equal. Then after you will subtract that equations. Okay, so multiply again by 10. Multiply by 10 both sides we get. Okay, in equation second I'm going to multiply 10 both sides. 10 into 10, 100. X is equal to, if you multiply 10 in this one, 3 comes to this side, 13 point, again 3 3 3. How many 3s there? 4. So you can write also 4 and so on. This is equation third. So from equation, see this one, equation second and equation third, 1.333. Here is 0.33. After decimal, the points are equal. It means that from equation third you can subtract the equation second. Okay, now subtracting equation second from equation third, we get, so right side 100x minus 10x is equal to, if you are subtracting, then your decimal point should be 0 and 13 minus 1, so I will write this one, and so on, minus 1.333 and so on. If you will subtract this one, then you will get this here 100 minus 10x, you get 90x is equal to, if you are here you will subtracting, then this term should be 0 and 13 minus 1, you get this 12. So then x is equal to 9 is a form of multiplication, goes to this side, division, 12 upon 90. If it is a cancel out by any same term, you will cancel this one. This cancel out by 3. 3 4s are 12, 3 3s are 9, 30. Again it is cancel out by 2. 2 2s are 4 and 2 15s are 30. So what you will get it? 2 upon 15, and it is not cancelled out by any other term. So x is equal to 2 upon 15, and what is the value of x? 0.1 dot. Hence 0.1 bar or dot, 0.1 dot is equal to 2 upon 15. That is your answer. Okay students, so by this way you can do other questions. I will give you one example. You can do with yourself. This is do it in your home as a homework. 0.14 dot, and one more is that one, 0.27 bar. Okay, so these two questions you can do with yourself students. Now this question number 4th. Firstly, suppose this one. Without supposing, if you are also doing, then you will get the same result. Okay, question number 4th from third 4th. Okay, let x is equal to 0.17 bar, means here is a two terms are repeating in one time. Okay, or you will write this one 0.171717 and so on. This is your equation 1. So if two terms in one times, if it is two terms are repeating, so you will multiply with 100. Okay, so multiplying both sides by 100. Okay, multiply by 100 both sides we get. If you multiply by 100, so what you will get, this 100x, two terms come to this side, 17.171717 and so on. So there is no any confusion students. You can see this one, here is the 1717 I have written 3 times, here is also, because and so on is there. Now you can increase 17 as much you want. Okay, so 17 comes to this side, 171717. So this is your equation second. See this one in your equation, 17 is there, 17 is there, means right side after decimal points it is equal. Then you will subtract equation 1 from equation 2. Subtracting equation 1 from equation 2, we get. And if we any doubt students, please ask that. Okay, our aim is to make this decimal number to the right side of your equation as a natural number. Okay, after subtracting we get only natural number, we want only natural number. Okay, so see this one, 100 x minus x is equal to, if you subtract this one, 17.171717 and so on, minus if you subtract this one, 0.171717 sorry 100 minus x, what you will get this one, students? 99x is equal to, if you are subtracting, you see this after decimal points it is equal, if you are subtracting you will get 0, then what is remaining here? 17.000 and so on. So after points only zeros, so you leave this one. So 99x is equal to 17, then x is equal to 17 upon 90, and this one is your answer. Okay, 17 upon 99, or you have supposed that x is equal to 0 point, hence x is a 0.17 bar is equal to 17 upon 99. So this is also easy. If you are getting two, if you're in your equation, in your question, if it is two terms are repeating, suppose 23 0.23 bar, if you want to do it directly, it is also easy. 23 upon 90, two terms repeating, 29, like a 0.3 bar 3 upon 1 9, 0.6 bar 6 upon 9. Here is also two terms are repeating, 29, 45 0.445 bar, then 45 upon 99. And I will give you some question, you can try it in your home. Suppose this is also for your homework. Try to do this question, first and second. I will give you that question. 0.16, easy, 16 bar, and one more I will give you this one, 0.234. okay, try this one to your home. Okay, so by this way you can do that questions. After completing this question number 4 of your exercise 3E, your chapter has completed. So you will revise this chapter, and if any doubts, please ask your doubt. Okay, and then after I'm going to start your chapter for fundamental concept of geometry, students. And please students, if any types of doubt related to your chapter integer, fraction and decimals, please ask, and I will give you that, I will suggest you will revise these 3 chapter. Okay, students, and try to solve other problems of your exercise. You will solve your example also, students, and prepare it for your first term examination. Okay, and I will reduce your syllabus also, and this it will inform you later. Okay, thank you, students.